So now we're going to take a look at what happens when we don't use tan, but we use the sine and cosine functions in solving for length. Now, as with the tan functions, we can solve for a missing side length by using the sine and cosine functions. Okay? In continuing from that previous video that we looked at on tan, the procedure of solving with sine and cos, or sine and cosine, is exactly the same using a different function. So we do the exact same thing. The procedure is really quite similar. Okay, here's our functions, sine, cos, and tan. And we're going to go through how do we use sine and cosine in this part to solve for a side length. The instructions that I have here, exactly the same as with tan. The only difference now is that we may not be using tan. Okay, we won't be in this case here. We're going to be using the sine and cosine functions. First step, we're trying to solve for x. We're given our angle theta. We need to label our sides. X is our hypotenuse. 11 is our opposite side, and our missing side here is our adjacent, or the side that we actually don't have is the adjacent. I still want you to always label the sides. Okay, always label all three sides no matter which one you're given or need to find. Okay, always label all three sides. Next step, using the given information, theta is 61 degrees, our opposite is 11 centimeters, and our hypotenuse is what we are trying to find, so that's our missing piece. We're going to then look at our three functions right here and determine which one of them has opposite and hypotenuse in it. Okay, opposite is what we have, hypotenuse is what we're trying to find. So that one, let's see, tan is opposite adjacent, nope. Adjacent hypotenuse, nope. Opposite hypotenuse, boom. We're going to be using our sine function to solve for this side length. All right, plug in our known information. Sine of 61 degrees is equal to the opposite side over the hypotenuse. Make that into two comparable fractions. And then, now because we're missing the bottom piece, we start on top. We cross multiply, divide, and that is going to equal to our final answer. So we're going to have 11 centimeters times 1 divided by the sine of 61 degrees. And let's see, let's put that into our calculators. 11 times 1 divided by sine of 61. Now again, we're using sine because that's the function we're using. That's the ratio that we're using as a comparison tool. And we get 12.58. as our final answer. Now again, I'm going to be asking you to put everything into two decimal places with length. With angles, I'm okay with just a regular angle. That's pretty good by itself. With a side length, we want to make sure we put it into as two decimal places for these questions here. All right, let's look at another one here. We want to determine the length of side XY. So that goes from X to Y. We're trying to find this side right here. We're given this angle, theta. So that means that we're trying to find the adjacent side. We have the hypotenuse, and the opposite side is just not there. We don't really need it in any case here. So then what we're going to do here is we're going to look at the information that we know. Theta is 38 degrees. Our hypotenuse, which we know, is 62 yards. And the adjacent is what we are trying to find. So we always have two pieces of information that we know, one that we are trying to find. All right, let's take a look at what we have here. We are looking for the adjacent. We have the hypotenuse. Which of our three functions has adjacent and hypotenuse in the function? Cosine. All right. So we're going to use our cosine function to solve for our adjacent side. So cosine of 38 degrees is equal to the adjacent, which we don't know, so I'm just going to put an adjacent in this case, over the hypotenuse, which we do know. Let's quickly correct that there. 62 yards. And we're going to put that over 1 so that we can solve for the answer. Now we start on the bottom, 62. We multiply, divide, and then that's going to equal to our adjacent side. 62 yards times the cosine of 38 degrees divided by 1, which doesn't change anything, but it's still important that we recognize that we are doing that. 62 times cos of 38 is 48.86 yards. So that is our final answer. This side is 48.86 yards. Now, if we were trying to find the opposite side, we would be using the sine function. We would not use cosine, we would use the sine function to solve for the opposite side. Let's do a couple more examples. We want to find the length of side A. So we're trying to find A right here. We're given theta as our angle. Label, that's our hypotenuse, or that's what we're trying to find. Our opposite is right there, and our adjacent is over here. So in other words, we're trying to find our hypotenuse given the opposite side. Information that we know. Theta is equal to 42 degrees. Our opposite is equal to 8 meters, and our hypotenuse is our missing side. So we need to find hypotenuse given the opposite. Take a look at our functions again. Sine has opposite and hypotenuse in it. Our question has opposite, and we want to try to find the hypotenuse. So we are going to use our sine function, opposite over hypotenuse. Please always write down which function you are using, and then plug in your values. 42 degrees is equal to 8 meters over something that we do not know. All right, start on top, cross multiply, divide, and that is going to equal to our final answer, 8 meters times 1 divided by sine of 42 degrees. Again, remember that multiplying by 1 actually doesn't change it either. So you don't have to write that down if you don't want to. 11.96 meters. Something to watch out for here, hypotenuse will always be the longest side, so if we get a shorter answer, that means that we made a mistake. Okay, then that usually means that we would have multiplied by sine of theta instead of divided by sine of theta if we got a shorter length for the hypotenuse. So be careful about that. Make sure that we recognize that it has to be a longer side length. Last example here that I want to go through is a contextual example that deals with a survey stake and pole. So if you look at the picture right here, we have a surveyor that sets up poles. He sets up his transit right here, which measures angles. He has a survey stake that he knows is 110 meters away from his transit. And there's a survey pole that he is pointed at to determine the length over the pond here. Okay, so we know this side here, we know this angle. Okay, here's our theta. Our adjacent side we know. Our hypotenuse is right here, and this is going to be our adjacent side. He is trying to figure out how long it is from his transit to the survey pole, which is across the pond from there. So we want to try to find the hypotenuse. Theta is 46.5 degrees. Our adjacent side is 110 meters, and our hypotenuse is unknown. So we want to try to find the hypotenuse now. If we take a look at our functions, cosine deals with adjacent and hypotenuse. So we're going to use our cosine function to determine what the hypotenuse is of our question here, of our contextual problem. What is the distance across the pond? Cos of 46.5 degrees is equal to the adjacent over the hypotenuse. Now we don't have a letter for hypotenuse, so we'll just write it in. we cross multiply and divide. Multiply across, divide by cos, and that's going to equal to our hypotenuse. So it's going to be 110 meters times 1 divided by cos of 46.5 degrees, and that's going to equal to our hypotenuse. Let's put it into our calculator. 110 times 1 divided by cos 46.5, and that is 159.8 meters across the pond. Now again, let's be careful about the 2 decimal places. This one rounded to a 0, so I just left it as a 0. Let's also be careful that you may have to do the angle before cos, you may have to do it after cos. Check your calculators. We'll go through it in class to make sure that you understand how to use your calculator.